Today's lesson is on special right triangles, and we're going to talk about the 45, 45, 90 right triangle. Okay, I want to be able to solve for sides in 45, 45, 90 right triangles. So we're going to start out by, we're going to use the Pythagorean theorem to get the ratio of my sides, which are the legs and the hypotenuse. So I'm going to start with a square. So with a square, I know all four sides are equal. And I'm going to start out with sides of 3. And then I'm going to draw in the diagonal. So for my right triangle, the two sides that form the 90-degree angle are called legs. And the side across from the 90-degree angle is the hypotenuse. Okay. So I want to calculate the distance of the hypotenuse. So I'm going to apply the Pythagorean theorem. And I know the Pythagorean theorem is a squared plus b squared equals c squared, where my legs are a and b, and the hypotenuse is c. So if I solve for c, I know c is the square root of a squared plus b squared. So substituting in a and b, I know that c is 3 squared plus 3 squared, which is 9 plus 9, which is 18. So this is the square root of 18. And I want to simplify this as my greatest perfect square. So this is going to be 9 times 2. So this is going to be c equals 3 times the square root of 2. Oops. What happened here? Who knows? Hang on. Here we are. No, I don't want to browse. How do I turn that off? Okay. All right. Let's see. It's going crazy here. There we go. Okay, so if my legs are sides 3, we said the diagonal is going to be 3 times the square root of 2. All right, so let's try it again with sides of 4. So again, c equals the square root of 4 squared plus 4 squared. So 16 plus 16 is 32, which is 16 times 2, because I want to factor out the largest perfect square. So this is c equals 4 times the square root of 2. So we have 4 times the square root of 2. So let's guess without doing it one more time. So if my sides are 5, this would be 5 times the square root of 2. My sides were 1, it'd be 1 times the square root of 2. My sides were any value x, it would be x times the square root of 2. Okay, so when I have a triangle that has two 45-degree angles and a 90-degree angle, I can see it a couple different ways in pictures. So I can see either tick marks or equal numbers here, or I can see that I have two 45-degree angles, or sometimes I'll even just show one as 45 with the right angle, and then I know the other angle has to be 45. So this is classified as an isosceles right triangle. Okay, so the way we're going to work these problems is we're going to make a table that looks like this. So I'm going to write 45, 45, 90, and then I'm going to write these ratios that we saw, 1, 1, and the square root of 2. And then whatever is in my triangle, whatever is across from 45, I'm going to fill in here. Across from 40, I'm going to fill in here, and whatever side is across from 90, I'm going to fill in here. And I'm going to set up, these are going to be equivalent fractions. And I'm going to use 2 of the 3 fractions and solve for my sides. All right, so let's do a couple examples. So how do I know when I have a 45, 45, 90 triangle? I think one of the obvious is I would see I have 2 45-degree angles and a 90-degree angle. I could see I have 2 equivalent angles, or I could see that I have 2 equivalent sides. So I can identify that I have a 45, 45, 90 triangle from several scenarios. Okay, here I have my table set up. So we're going to solve for the variable. So I'm going to set up and I'm going to write 45, 45, 90, 1, 1, the square root of 2. And then across from 45, I'm going to write that I have 8. And since this side is 45 and this side is 45, I know this is also 8. And across from 90 is x. So these are 3 equivalent fractions. So to solve for the variable, I just need to set 2 of them equal. Of course, I need to have one that has the variable. So this is going to be 1 over 8 equals the square root of 2 over x. So to solve for x, I'm going to multiply 8 times the square root of 2, and I'm going to divide by 1. So x equals 8 times the square root of 2. Let's try number 2. So same thing, I'm going to write 45, 45, 90. And then I'm going to put the ratios 1, 1, the square root of 2. I know I have a 45, 45, 90 because I have 2 equal angles. So I know these 2 are 2 equal sides. So I know these 2 angles are equal. So across from 45 is x. If this side is x, this side is also x. And across from 90 is 16 times the square root of 2. So here I have 3 equivalent fractions. I'm going to choose 2, one that includes the variable, and solve. So I have 1 over x equals the square root of 2 divided by 16 times the square root of 2. So I'm going to multiply x equals 16 times the square root of 2 divided by the square root of 2. Anything divided by itself is 1. So the square root of 2 divided by the square root of 2 is 1. So I'm left with is x equals 16. Okay. Okay, so I cannot have a radical in the denominator. So when we are working in the denominator, there cannot be a radical, no radicals. So I need to, what is called, rationalize the denominator. So I'm going to multiply times 1, and this 1 looks like whatever's in the denominator. So we practice this with simplifying radicals. Okay, so I recognize I have a 45, 45, 90 triangle, so I'm going to make my table that says 1, 1, the square root of 2. So across from 45 is x. So this is also x. And across from 90 is 16. So I have 3 equivalent fractions. I'm going to set 2 equal to each other and solve. So this is 1 over x equals the square root of 2 over 16. So x equals, did I write this backwards? 1 over x. So x equals 16 times 1 divided by the square root of 2. So now I need to rationalize my denominator. So I have a square root of 2 in the denominator. So I'm going to multiply times the square root of 2 times the square root of 2. So now I have 2 fractions. So I'm multiplying numerator times numerator. So 16 times the square root of 2. And the square root of 2 times the square root of 2 is 2. So now I need to simplify 16 divided by 2. So I get x equals 8 times the square root of 2. So now we're putting together simplifying radicals and solving for the sides. All right, let's try one more. So I recognize I have a 45, 45, 90 triangle because I have 2 equal legs. My legs are equal. Then these angles must be 45 degrees. So if this side is 10 times the square root of 2, so is this side. So across from 45 is 10 times the square root of 2, 10 times the square root of 2, and across from 90 is x. Okay, so I have 3 equivalent fractions. So I'm going to set 2 equal to each other, and it has to include the variable. Oops. Okay, so I have 1 over 10 times the square root of 2 equals the square root of 2 over x. So x equals 10 times the square root of 2 times the square root of 2 divided by 1. So the square root of 2 times the square root of 2 is 2. So this is 10 times 2. So 10 times 2 is 20. Okay, that's it. Oh, I wonder if I stopped. Did it stop with all that drama? I have to try again, I guess.